Perfect. Well, welcome, and thank you for joining us today as we look at the critical role that endpoint security plays in securing your OT and IoT environment, and how with Nozomi, you can get better visibility, enhanced threat intelligence, and faster response times to the threats that are facing your organization. I'm Brian Uffelman, product marketing here at Nozomi, and I'm joined with Gabriele Weber, our product manager for Endpoint, and also by Gabe Guillen, our technical marketing engineer. We're going to move fast, but as an overview, we're going to start by looking at the overall market trends and customer pain points. And then we'll look at use cases and real-world examples of the specific endpoint security concerns facing OT and IoT, how we at Nozomi uniquely solve these challenges with our Arc product and broader platform. And we'll have a live demo so you can see the solution in action, and then we'll get to your questions. At Nozomi, we address the rigorous challenges of securing OT and IoT by protecting everything in your environment, from the endpoint to the air and everywhere in between. And before we jump into the platform and our endpoint security capabilities, I wanted to take a moment and consider what's driving OT and IoT security to the endpoint in the first place. This chart here shows the percentage increase in the number of OT cyber incidents relative to the previous year. So we've got this hockey stick effect going on in terms of the number of attacks happening every year, and we don't see that plateauing anytime soon. It's going to continue to grow at increasing rates. And why is that important? Because these attacks have real-world impacts for your business. There's over 800 OT and IoT cyber incidents per day. That's just an average over the past year. Each of those attacks have real-world dollars behind them, with the average cost of an attack being, $5 million, upwards of $5 million. And that number is specific to OT because downtime really equates to dollars lost in the OT landscape. Many of these are ransomware attacks that spread from the IT side of the house as convergence between OT and IoT increases, or they're specifically directed at the OT environment itself. And while ransomware is a top concern for any organization, these types of attacks are especially relevant in OT and IoT, where critical systems can be shut down, causing downtime. And again, that downtime translates to dollars and revenue losses, in addition to the physical damage and safety concerns that these types of attacks can have. And the sources of IoT and OT attacks can vary. You've got nation-state actors who are well-resourced driving some attacks, ransomware groups seeking to extort organizations. These are some of the high-profile attacks that we've seen, again, over the last few years. And they're also the most expensive and, one of the drivers of the high costs of attacks that I highlighted earlier. You also have hacktivists who are looking to make a statement by causing disruptions in OT and IoT. And this is significant because those hacktivist attacks are actually, on the upswing, and they drove more than 15% of the attacks that we saw last year in 2023. That trend is going to continue. And then you have insider threats. These are employees, contractors, or other individuals with legitimate access to OT systems who can either inadvertently or maliciously cause security problems for your business. And that's because, or what we've seen over the past few years is that insider threats actually drive up to 60% of OT cyber incidents. Again, that's not always malicious in nature. Sometimes these incidents are caused by misconfigurations or security lapses. And as we look at the OT endpoint specifically, we've seen that endpoint attacks are on the rise. When we look at data from the MITRE ATT&CK framework, 72% of all OT attacks are focused on the endpoint itself. These can be typical Windows or Linux devices, and sometimes they're legacy devices, and therefore difficult to secure with traditional endpoint security solutions. They're things like application servers, gateways, or HMIs, and workstations in the OT environment. Before I hand it over to Gabriele to talk about use cases, I did want to talk a little bit about the uniqueness of OT and the OT side of the house when we're talking about endpoint security. The differences between OT and IoT, because these endpoints and assets that we're trying to secure in the OT environment are very different than the assets on the IT side of the house. On the IT side, there's the need to support digital workflows, Data protection is key, with a lot of the focus being on identity and access management as a means to secure applications and data. And the concerns are centered around risk, vulnerability management, automatic patching of devices, which is not something you see in OT, or could actually cause problems in an OT network, and then ensuring that IT assets are up to date. All of this is managed by traditional endpoint protection solutions that don't necessarily fit in the OT world. On the OT side, we're focused on securing the actual physical processes themselves. Top concerns are operational resilience, making sure that systems are working, safety, and ensuring availability and uptime. OT security is a top concern, and that's why we're all here today. But historically, it's also been a little bit of an afterthought, which is scary because all of the considerations from IT plus things like downtime, which again are measured in minutes and hours in the OT world. And we saw how quickly those can stretch into millions of dollars for any one cyber incident. You have to be concerned also with employee safety and environmental safety. And we've got unique protocols that differ from IT. So we're not just securing legacy systems that are high-value systems, or we're securing high-value systems. This is an iPhone or a PC that can be easily replaced. So how do we do that at Nozomi? Nozomi addresses all of the concerns and considerations that I just kind of walked through, and we address it with a scalable, multi-tier, AI-driven platform that provides security for your entire environment. The platform includes Vantage, which is our cloud management platform that unifies security monitoring and can do this on a global scale. And we'll discuss specifically how our endpoint solution can connect directly to Vantage for greater visibility and threat intelligence at the endpoint layer. We've got Guardian, which is our on-prem solution for monitoring OT and IoT networks and assets. Guardian Air, which can extend that visibility and protection across the wireless spectrum, because in an OT environment, more devices are becoming wirelessly enabled. You've got remote connectors. And then finally, at the endpoint level, we have Arc, which is our endpoint sensor that provides the visibility and security at the endpoint or asset level. And this is where we're going to be focusing our discussion today. And with that, I'm going to hand it over to our product manager, Gabriele Weber, to discuss some of the use cases and real-world examples that we're seeing in OT and IoT.
Thank you, Brian. So indeed, we want to show you with these use cases some problems you may come across as Nozomi users or as OT or IoT workers in general, working in this field we are tackling. And let me start with the first use case and problem, which is about visibility, just mere visibility. So most OT traditional tools rely on either just passive or also active queries. We also rely on active queries as well. By the way, our smart polling is. So there are limitations relying just on these two approaches. So passive is limited because we cannot intrinsically see all the messages we would like to see for realizing best visibility without soliciting the system, and that's one limitation. For active queries, we can have better visibility, still less granular than with an endpoint sensor. A problem, there are two challenges with active queries. One is throughput, because we may want to have some kind of continuous sampling, right? But having continuous sampling on the information pulled by an asset, especially for Windows assets, can determine high throughput, and this may be not desirable, especially in critical infrastructure OT networks, right? So we can decrease the sampling of this information, the polling frequency for this information, but then we end up not having continuous visibility. The other one is related to maybe well known to you, the Purdue model. Queries can be shot by a different segment of the network from which the target asset is, and this may also be undesirable, okay, making active queries a suboptimal solution. So the greater visibility we can offer with Arc is related to user activity, is related to level 0 and 1 visibility in details for 2D model, application behaviors, USB devices, we're going to see in the next slides as well with more detail, and changes in logs, Windows logs, operating system logs that determine that are a symptom of malicious actions, PowerShell executions, malware executing, and such. Okay, so Arc, all in all, offers a deeper level of visibility, so more context and more accuracy than the other two mentioned methods. Second use case, physical access. You may know how important is physical access in OT systems and in IoT systems as well, where something physical, in fact, is controlled behind the IoT part. And imagine you have a network that is very well defended from a firewall point of view, from a network segmentation point of view. Now, if you leave it open, the physical access, that's definitely a possible breach, right? That's a high danger. So, and again, for malware and data exfiltration. So what we can do with Arc is, in fact, from a physical access control point of view, is we can monitor USB devices, if a media is connected, if malicious USB are connected, so the so-called bad USB devices, they could aim for keystroke injection, they could aim for keylogging, right? And this is one part, but also we can monitor other physical parts of typical OT and IoT systems, such as PLCs. So we are able to spot if a cable is disconnected from a PLC. We're able to spot if a device module is detached from a PLC. Excuse me. So all in all, we're able to offer some solid physical access control measures. Use case number 3. You may belong to nuclear vertical, or you may belong to some oil and gas company, or any vertical requiring high security through air gapping the system. This means no connectivity or limited connectivity is granted to these facilities, to these environments. Here we want to bring up a vessel example that could meet the case, in fact, the use case, where in fact there is satellite connectivity, it goes back and forth. We cannot rely on something that is related to that continuous connectivity. And as such, with Arc, we offer offline data extraction. So we can extract from each asset the data related to the asset itself and the network surrounding it, to then import it into our main consoles when connectivity is granted. By the way, computers in our networks are about 5 to 10%. So this means that this amount of assets can be monitored by Arc. On top, with Arc embedded, the last born in our family, we can monitor PLCs from within as well. So this percentage of assets increases. So air-gapped unlimited connectivity environments. The next use case, and let me continue with the vessel example, relates to operational costs and ability in general to deploy hardware or virtual machines. Now, imagine we are still on the same vessel, and for now, connectivity is granted. So we got rid of the connectivity problem. Still, such environments, imagine you're in a it could be a cargo vessel, or it could be also a cruise ship with bunks. Not a suitable scenario for pulling many cables. You don't have such a big server room hosting more pieces of metal there. So definitely not the ideal place to deploy infrastructure. In this sense, we offer a completely hardware-less, infrastructure-less configuration infrastructure, connecting Arc directly to Vantage. So not only you don't need the hardware, you don't need virtual machines either. We're just relying on installing this software on the assets we want to monitor, connect them up to the to the cloud where our Vantage resides, and then you can get full visibility without any deployment. Of course, this determines also a variation, an improvement, better said, in operational costs, because you don't need to manage infrastructure, you don't need to manage virtual machines, you don't need to manage hardware to be replaced. Now, connecting to Brian's introduction here, another structural problem is the incompatibility with natively IT tools. There are several constraints in OT and IoT networks, and they relate to knowledge of the protocols of the languages that are spoken in such environments. That's for sure one. Another one is because we don't take down the physical system nor the IT system driving it, performance utilization is very important. And so we designed our solution ground up in an OT and an IoT way. So this means we don't need any reboot. We do know all the protocols and languages that are spoken in those environments. And very important as well, we are a user space software instead of being a driver, instead of being kernel-based, because we don't want to impact whatsoever the functionality of such workstations or PLCs that host our Arc product. So IoT, OT design system ground up. Now, to tackle all of the above, of course, the solution we came up is Arc. What is Arc is again, user space software executable, compatible with the most widespread operating systems. We're compatible with Windows down to Windows 7. We're compatible with Linux. We support most widespread distributions such as Debian, Ubuntu, CentOS, SUSE, Red Hat, and also with macOS. And finally, we are now also compatible with PLCs. PLCs can host Arc. So introducing this at high level, now I want to show you in the next section some more in detail functionalities that we are offering to our customers. And let me start with defining the fact that we have two dimensions. Arc is both an asset sensor and a network sensor. From an asset sensor point of view, these are the big features, the main functionalities we put on the market. The first one relating to the use case we just saw is related to physical access control, right? Again, USB, hardware changes, continuous monitoring. Second one is user activity correlation. How handy it is to know from an incident response point of view, from an accountability point of view, to know what user was connected to your Windows machine, to your machine when an alert triggered, when a certain event happened. So we are able, thanks to being on the host, on the physical asset, to relate events with human users, but also process users for some specific alerts that were responsible for some event to happen. The third point is behavioral analysis. We are using a technology which is, you can Google it online if you're not familiar, is an open source syntax. It's called Sigma. It's a way to describe in a structured and computer readable manner, of course, local events. So for the first time in Nozomi history, we are able to spot events that are local, of course, without implying any network artifacts. And Sigma rules especially are very strong in, as I was mentioning earlier, spotting PowerShell executions, changes in files, ransomware acting credentials stolen from your web browser, and such. So behavioral, we are adding this onto our network analysis, local behavioral analysis on the host. The continuous asset monitoring and vulnerability assessment is about extracting a variety of information in real time, which is resource utilization, of a given machine. It's about hot fixes, of course, for vulnerability assessments. It's about install software. It's about make a model of a specific device. It's about users again. So defining what an asset looks like from a pure visibility and vulnerability assessment point of view, even before threats are monitoring. And the last one we are working on is protection. Protection will be also a breakthrough in the sense that we are enforcing some actions, and the actions we're enforcing could be blocking a USB, could be quarantine a file, it could be killing a process, it could be acting on a local firewall, will be performed both from a workstation and from a PLC as well. So this is the potential of it combined with installing both on workstations and controllers. Coming to the second dimension of Arc, network sensor, right? So continuous traffic monitoring is the passive engine of it. And again, it inherits every protocol knowledge we have gotten in Guardian and Vantage, so the other products in the platform, because data is processed there, in fact, to remain very lightweight. On top of which we have added discovery measures, which is lightweight network communication, broadcast in order to discover neighboring devices. And on top, we have smart polling as well. Our active queries now from the PLC as well. So, sorry, from the Arc host as well, which can be the PLC or workstations. Now, this solves already the problem of having externally sent messages from an active query point of view, and we can do it from Arc as well. So we combine the power of the two. And this was the second dimension of the endpoint sensor. Last born in the Arc family, and we are very proud of this. We think we have been super innovative in the industry we work on. We did something that nobody else did before. We are installing Arc on a PLC, and this is what we can do thanks to this technology. First of all, Arc native features. We do inherit any detection we have on workstation on the PLC as well. So continuous asset monitoring NVA and network visibility. Now, network visibility moved even one level down in the PureView model, so from an unprecedented position. On top of which, we can add protection and compliance. So I see them as two sides of the same medal, as in we need to extract information from the asset to then either do some reporting and tell you if you are deviating from a given baseline representing a regulation, company regulation, or a state regulation, or enforcing actions like we do in protection. We are able to spot and identify chain configurations. It means take an external asset connected to the main asset on top of which Arc is via serial, not via Ethernet. So via different communication means, we are able to spot that, identify. Remote IOs could be a good example for this detection. Program changes also very big. We can do ladder logic analysis or implications of it, like when a program is changed in the PLC, potentially impacting the whole process, and we can do that. And finally, level 0 visibility. We are now unlocking the potential of this part. We could do comparison between variables at level 0 and level 1, and we're checking use cases here in order to unlock that potential. But we have the data, and that's the visibility we can get with Arc Embedded. Now, one slide about possible attack scenarios we can cover with this technology. We can cover first group type attacks is a process-related type attacks. In this specific case, is about flickering some process variable. In Destroyer was similar type of attack here. So in general, things happening to the process, we can detect. Number two, also very important, someone is impersonating an engineering workstation to stop the PLC program. So all of a sudden, any emergency button to stop the process when something is bad because we need to stop it for human safety, for example, it's not going to work anymore because the PLC was stopped, and we can spot that. As well as we mentioned, hardware-related changes, like a cable is disconnected from a PLC, so network communication is not going to happen. And this, we do it, worth noting, from within the PLC, because one may argue, hey, if you disconnect a cable and then Arc communicates through that cable, how can you know it was an attack? Or, of course, when we also know when Arc is not communicating, but with Arc embedded technology, we can see from within the PLC when this happens, as well as a module is disconnected from the PLC. Imagine you detach a module just by a few centimeters, it looks like it's okay. Again, the process is impacted and endangered. And as last, I want to mention again, if someone changes the program of the PLC, changing logics, changing the recipe for a pharmaceutical site, you name it, we can spot it. Excuse me, I was meaning ladder logics in the previous point, but also what I didn't say is on local state. So we can see if something is running, not running, if basically the LED panel of a PLC, we can put it inside out and tell the user what are the functions that are running, what are the functions that are not running. Good, so before I pass it to Gabe, let me close it with the differentiators our product shows to the market. Again, is built ground up for OT IoT environments. And as this conjugates into having, number one, we are a user space solution. We don't need any reboot for deploying it on the target machines, lower resource consumption, excuse me. We can try it out. We can work with a really little amount of RAM, little amount of disk available, and we have support for legacy operative systems. Again, we are a two-in-one solution because we have the asset-based and network-based, and we have support for air-gapped scenarios as well. With this, I will pass it to you, Gabe, for your demo.
Awesome. Thank you very much, Gabby and Brian. I am going to be sharing with you guys what the Arc looks like. So this is my desktop. Guys, feel free to put your questions on the Q&A panel. So now we have the expert having a look at the Q&A. So go ahead and throw your questions over there. So this is the actual Vantage account. So this is my Vantage account. But remember, you can have Arc connected to Guardian. So it doesn't have to be cloud. It can be on an on-prem solution as well. And the look and feel is going to be very similar to what you are going to see right now. So before going into what the demo is on Arc, I want to show you the different sensors. We had quite a few questions about this particular topic. So I want you guys to see here that we have, for example, Linux sensors, we have some Windows sensors, we have some Mac OS sensors, and one embedded sensor over here, meaning that we do support, as Gabby said, we do support a wide variety of operating systems and versions of operating systems, including Windows 7, by the way. So Windows 7, which is rather old, we do support that. So if you have these type of machines in your environment, which is highly probable, you will be able to use Arc to secure your environment, to help secure your environment. So I have a bunch of Arc instances here, quite a few. This is a Arc lab. So this is the very first thing I wanted to show you. Now, let's go back into, well, actually, I want to go into the alerts because Gabby was telling us about a couple of use cases that I found very interesting. One of them is Sigma rules. You can see Sigma rules like right out of the list. So top of the list, you see Sigma rules here. So we do support Sigma rules, but apart from that, we do support as well USB activity or USB monitoring. So if you go here into the name, you can see that you can filter easily just by clicking Sigma rules, which I'm not going to do. I'm already seeing them here, but I can click on USB transfers as well. And I will be able to see USB file transfers, which is obviously related to somebody that is copying files or transferring files. And this is related somehow to a USB device. You can say, well, it's obviously a thumb drive. Well, you never know. I mean, it could be a device that is faking like a thumb drive, is acting like a thumb drive, but it's not a thumb drive. It could be a keylogger, for example, that is saying, well, I'm actually a keyboard, but I'm not a keyboard. I'm a keylogger, so I'm actually recording all the strokes that you have that you have performed in your machine, different things. But anyways, let's go ahead and click on the USB file transfer. I'm doing this randomly, and I can see that there has been a transfer of a file in this computer that is called fanless and this IP address, and where is it located, etc., etc. So I'm going to take note of these IP address, and I can go into the assets, for example. This is the entire asset list. So you can see how can you have a visibility on the different assets owned by types, vendor, OS, but that's not part of these. I just wanted to have you to have a look at it. And then if I go here into the IP, I will see this fanless device. So fanless is a computer. So you can see a whole bunch of details here. But the most important thing, and that's related to what we are talking today, is Arc as the source of the information that we are seeing. So you can see Windows 11 as the OS or firmware. You can see that this is a Google device. It's a computer, all the IP addresses, MAC addresses, nodes. We even calculate the risk of this device, which is part of another session. But we have an excellent amount of details, including software that has been installed in this computer. So look at all these software packages that we have identified as being installed in this computer. Beyond that, the alerts that are related to this, obviously USB file transfer is one because I just came out of it. But you can see all the alerts that are associated to it. And Arc is helping us getting the maximum amount of information out of this particular computer. Now, I want to go back into the alerts and have a look at the Sigma rules. So I'm going to click on one Sigma rule match, which is this one in particular. So Sigma rule is telling me, hey, you have this problem. So detects driver load events. So one computer, once again, it's not fanless. Now it's another computer. It's called IntArc2. It's matching this particular event, this particular Sigma rule. So we can go back to the asset list, as we said, as we did before. Let's have a look at this computer. Instead of being the previous one, fanless, it's now IntArc2. It looks like a virtual machine. So it's VMware, it shows us the vendor, and it says it's a virtual machine over there. So let's click on it, and you will be able to see the same thing, right? So instead of being the other computer, it's this one. This is a Windows 10, the source is Arc, and then you can see serial numbers, you can see versions of software, you can see vendors, the type, all the IP addresses that have been identified, the activity of the asset, depending on the hour and the date, and of course, something that is rather interesting, the communications graph. But Arc is giving us a lot of details. Beyond the software pieces installed on this computer, you can get information like, for example, the CPU load, the RAM that is being utilized, the disk use space, the amount of CPUs that we have configured here, the amount of disks, and so on, as well as properties, the users. You can correlate users that have been active when certain events happen. So let's say somebody plugged in a USB key, which I'm not showing you right now, but if somebody plugs in a USB key, you can get an alert for that particular event. And of course, if something happens afterwards, you will want to implement an accountability measure. So you will want to know who was active at this point in time when all these things happen. So If we go to software, the same thing. We can get all the software pieces that are installed in this particular computer, the alerts that are associated to it, and this is thanks to Arc. Now, before wrapping up, there is one more thing that I want to show you guys. So Gabby mentioned smart polling, and it happens that you can actually run smart polling from Arc. So usually computers with Arc are closer to the devices than regular, let's say, Guardians, or even, of course, Vantage, which is in the cloud. So if you're closer to the device, you will want to implement a technology like smart polling plus Arc, because you will be able to gather this information without violating the inter-level communication that the Purdue model establishes. So you don't want to violate that. You don't want to mess with that. So if you're a purist and you want to have 100% compliance, Arc is your best friend here. So now you implement Arc, and then you utilize smart polling to gather the information from those devices that are closer to this. So let's go ahead and click, for example, in OT devices, because I can actually filter here as well. And I will see a bunch of elements. Now, you can see that not all of these devices will have firmware associated to it. So some of them will, but not all of them. And if I click on one, let's go ahead and do this Rockwell device. Rockwell device, it's going to give me this information in high confidence, and the source is smart polling. Smart polling can run either from Guardian or it can run from Arc. So this can be easily obtained by an Arc computer that has smart polling running on it. So conclusion is, I can get more information. I can get more details about all the computers and the devices that are surrounding it, including, because you can do this from Arc Embedded as well. So we discussed Arc Embedded, Arc installed inside of a PLC. Now imagine Arc inside of the PLC and running smart polling and get against other devices, could be other PLCs without Arc installed, from the PLC that has Arc, and gathering all this information and sending it out to either Vantage or keeping it inside using Guardian, and then having all this information, all this visibility, and definitely securing your environment even more. Last but not least, if you want to have a look at what is actually installed on the computer, I am going to show you like the Arc agent in my computer. So this is what it shows. So it's fairly easy. It's installing the user space. It doesn't mess with the kernel at all. So no risk at all. This is not gonna jeopardize the stability of my computer. And you can see here that it's fairly simple, right? So in the case of my computer, it's a Mac computer, so it has only one dependency. Windows computers will have more that allows you to do more things. 3 more, if I remember well. You can see generic information about which version of Arc is here and the configuration, including the upstream connection. Or if you want to go ahead and implement, like, for example, offline mode, which you can. So let's say you have a bunch of computers that are offline. You can implement Arc, gather this data. You go here and you gather this data, and then you take that data physically, so with you, to another computer, and then you can put that in the Guardian or in Vantage and analyze all this. So that's why it's called offline mode. So with that being said, I'm giving the control back to you guys. Thank you very much.
Perfect. Thanks, Gabe. So just to reinforce what Gabriele talked about and what Gabe just demonstrated, with Arc, you have the ability to gain greater visibility into assets and users and data on your OT and IoT environment. We've got enhanced threat detection as well, with a solution that was designed specifically for OT. All of this giving you greater accuracy on potential threats, alerting you of anomalous behaviors that are indicative of threats to your network. And so with the visibility and threat detection combined, we can deliver those faster response times to threats that you require to keep your systems running. Because we're not sitting directly on the OT, or because we are sitting directly on the OT endpoint or host itself, wherever that endpoint is in the network. Arc can instantly respond to threats at the lowest levels of the network, allowing you to defend those high-value endpoints, and then delivering that operational continuity and resilience that your organization requires. As we close today, there's an opportunity for you to engage further. We've got in the chat, I placed a link where you can reach out to schedule a follow-up meeting or demo. And as you exit today, you'll also be left with a link to a blog where we talk about endpoint security and how OT security is moving to the endpoint, where humans and those OT endpoints interact. With that, what we'll do now is we'll open it up for Q&A from Gabriele and Gabe. If you see any questions in the chat or in the Q&A that you want to answer, let's take a look at those.
Yes, let me take the opportunity to answer live to a couple of the questions that came in. An anonymous attendee is asking if the Arc as an asset and network sensor are if Arc and Arc Embedded are the same software configured differently, or are they two different code-based solutions? They are the same code base, and in fact, when Arc determines that the environment surrounding it is different, it will behave with more detections, knowing that it is in a given PLC and given technology. So that's the first question. So for the sake of maintainability, that's what optimizes our development effort, and Arc will be smart enough. Second question from Reem Jashan. For the PLC embedded option, what are the supported vendors? So we have one released supported vendor, that's Mitsubishi Electric. With Mitsubishi Electric, we have an agreement that the version of Arc Embedded, so we can have only their version for the next 6 months. And so we're going to have that one for these 6 months. Meanwhile, we're doing research and development in our labs, and we have our next candidate technologies. What we mentioned about Arc Embedded is because we see that as a reality in what we have out, and as the same potential for the next technologies possible. Okay, so that's the answer. I hope it answered enough.
So, any others, Gabriele or Gabe, that you see that you want to take a poke at?
Actually, I have a counter question to Anthony Gunn. So on smart polling, I say we could do away with packet broker or port mirror to gather the same information of all assets. That's the question. But device would still have to communicate with Guardian. So what we want to emphasize in this presentation is that yes, but there is anyways some information that never flows from a passive point of view. And then from a smart polling point of view, well, it depends. It depends. So it could be a feasible configuration. It depends on the case. So staying on the asset anyways is a working solution. And then how smart polling is effective, it depends a bit on the case. I don't know if you want to elaborate more on this, or we should move forward.
I think we can move on. Gabe, any that you see that you wanted to take a crack at?
Yeah, an anonymous attendee is asking us if Arc is a different product than Guardian, and it says Guardian as an earlier thing. Guardian is not an earlier thing. Guardian is a current thing. So Guardian is our on-prem solution, and Arc is a different product for sure. So we do work with both Guardian and Vantage, and I want to make sure that everybody here knows that. So you can implement Arc either as an offline mode, you can connect it to Guardian that is going to be on-prem in an air-gapped solution, or you can either connect Arc directly to Vantage. And that's what Gabby was referring to hardware-less. So we have plenty of options to utilize Arc. So that's the one I wanted to tackle. You see any other thing over there, Gabby?
Does Arc have auto-discovery of asset capabilities? Yes, definitely so. So again, as a network sensor, it combines passive detection with discovery capabilities with smart polling capabilities. So all these three levels. So the answer is yes.
Okay.
Yes, I see another one here from Marian. I know it's hard to say, but what is the throughput? What is the throughput coming out of Arc? Well, there is no answer there because it just depends on the traffic around the asset we are monitoring. So what I can say is that the overhead that we add is basically zero, is negligible. Then depending on whether an asset gets more or less traffic, we can monitor it all. By the way, we can selectively enable different network interfaces to enable network traffic monitoring or not. And then we just depend on the network traffic, more or less, that it will be.
Cool. There is another one here. Anonymous attendee. He's asking, or she, when would you use remote collector versus Arc? That's essentially a different thing. So remote collectors gather a copy of the traffic, sends it back to Guardian. Arc is an agent that is installed in the user space of hosts. So as I showed in the demo, you can gather information that it's inherent to the host. So like software packages are installed, like USB activity, among other things. That's essentially a completely different thing from what you can achieve using a remote collector. All right, what else do we have here? We have a couple more.
Sergio is asking about how a SOC certification is for the financial sector. So the SOC 2 that we mentioned in our certification page is something relating to IT products. So it's not only for financial. It relates, and by the way, even when we monitor OT, we are, so please follow me here. We are still an IT product. We are not an automation product. We are an IT product serving the OT world. So SOC anyways applies also to our product, and we took it.
Some people is asking about training on the different tools. I would encourage you guys to have a look at the blog, and you can reach out. We can reach out to us. I mean, if you need to have one-on-ones, we can put you in contact with the right people, and then you can get a one-on-one session where we can show you what Arc and the other tools can do. So I'm gonna put here, guys. If you can do that, you can put one of our emails in the chat, because I don't have permission to do that. So for those of you guys that want to go ahead and schedule one-on-ones, please go ahead and do that. Feel free to use.
Okay. Well, questions are kind of winding down. I just want to take this opportunity to thank all of you for joining us today. Check out the links in the chat to dive deeper and engage with Nozomi, as well as take a look at the blog. And as Gabe mentioned, feel free to reach out to us directly or through the links that were provided in the chat. With that, we're going to wrap things up. And again, thank you for joining us today. Thanks, Gabriele and Gabe as well.
Thank you, everyone, for joining.
Thank you.